Okay, so if we'd like to optimize a problem, there are a series of steps we need to go through. And they're given up here. We don't always go through every step, and it depends on the problem we're given. But we need to always understand the problem, and then we may want to draw a picture of the problem, and then give names to the variables in the problem, come up with a formula that we need to maximize or minimize, and then go ahead and take the max or the min. And so we can remember this with you draw names for max min. So we can remember where we are on the process if we have that mnemonic. Okay, today we want to talk about optimizing photosynthesis. So phytoplankton photosynthesize, they live in the water, but the rate at which they photosynthesize depends on the intensity of the light. Now, the rate of photosynthesis is in milligrams per meter cubed per hour, and the intensity of the light is in thousands of foot candles. And there's a formula given here. So we're already at the point where we've got the names and the formula, and the formula is given as 100I over I squared plus I plus 4. Now the question asks, for which light intensity is the photosynthesis optimal? So we might want to draw a picture here just to get a sense of what's going on with P. And you'll notice when I is equal to 0, P is equal to 0. So P goes through 0, and the limit as I goes to infinity of P of I is equal to the limit as I goes to infinity of 100I divided by I squared plus I plus 4. And if we divide the top and the bottom by the highest power in the bottom, then we can see that the top goes to 0, and we have the limit as I goes to infinity, 100 over I over 1 plus 1 over I plus 4 over I squared. And this will be 0. And so out here, where I is very large, the P will be 0. So we think we're going to have a function that maybe goes up and comes down like this. And we'll get a better idea once we start taking the derivative for P. Okay, so we're going to look for the maximum. We want to know the value of I that gives the largest value for P. So our next step is to actually compute the derivative. And here we have the function. So now we need to use the quotient rule. And so we write P prime of I is equal to low d high minus high d low. Draw the line and square below. Okay, so if we expand this out, we have 100I squared plus 100I plus 400 minus 200 I squared minus 200 minus 100, I should say, I. And then we have the denominator, which is I squared plus I plus 4, all squared. And you'll notice that these two terms cancel, and then we're going to have that this is equal to 102, 4 minus I squared over I squared plus I plus 4, all squared. Okay, so we want to find out when P prime of I is equal to 0. Okay, so if we set P prime of I is equal to 0, we know the denominator is always positive. Okay, this is always positive here. And so we're going to say that means that I squared is equal to 4. And because I is greater or equal to 0, this is going to say I is equal to 2. Okay. So let's now look at the sign of P prime to see if the function is increasing or decreasing. And so we'll have the interval here. And we'll have 4 minus I squared. And then we'll have P prime and then increasing or decreasing. And remember, we start at I is equal to 0, and so we go from 0 to 2, and then we go from 2 to infinity. Okay, so on 0 to 2, 4 minus I squared is going to be positive. P prime is going to be positive. It's going to be an increasing function. On to infinity, 4 minus I squared is going to be negative. P prime is going to be negative, and it's going to be decreasing. And so I equals 2 is a maximum by the first derivative test. Okay, there's another test we could use here if we wanted to, which would be the second derivative test. And so we'd have to compute P double prime, and for a maximum, we'd have to make sure that P double prime was negative. But you have a choice of whether you use the first or second derivative test when you do these kinds of max-min problems to optimize. And in this case, it's good to do whatever is easiest. And here, we've already done all the work. We realize on 0, 2, the function is increasing, and on 2 infinity, it's decreasing. So we can just use a first derivative test, and we don't have to take a second derivative here. And so we have I is equal to 2 is the value where the photosynthesis is optimal. Okay, with respect to these last two questions, I'll just kind of talk my way through these. So in the ocean, the light intensity might decrease as you go deeper in the ocean. And so you might expect to find the phytoplankton at a level where the intensity is 2,000 foot candles. And so they might go up or down in the ocean so as to get the optimal level of light intensity. Now, if the light intensity varied with time, maybe a cloudy day or a sunny day, then that intensity could move up and down in the ocean, and you might expect the phytoplankton to move up and down so as to track the best light intensity. And that's actually what phytoplankton do. You can see them moving up and down in the ocean, tracking light intensity so as to optimize photosynthesis. And isn't that cool?